Well, hello, Math 10. We're going to be taking a look at question number 4 from 8.1. This question is possibly pretty hard, so let's find out how to use it. We'll just remind ourselves that we have at our disposal some trigonometric ratios. That's such a fancy word, isn't it? Just some knowledge we have about right triangles, and guess what? We have two right triangles here. To know that if we know sort of some relationships of their sides, that can tell us about their angles, and also vice versa. If we know about their angles, we could talk about the relationships between their sides. We got some interlocking triangles here to make it harder, but it's still going to be the same sort of trigonometric stuff. So don't forget so, ka, toa to remind ourselves of our ratios that we have at our disposal. Also, we should probably remember we have the Pythagorean theorem. So I will just stick that up here to kind of remind myself of the tools that I have to solve this question. So we are looking for side AB. Really important to remind yourself that's the main thing you're looking for is a side length. So I'm going to probably try to figure out either figure out some information about these sides, or I'm going to try to figure out some information about another angle or something. I don't know. We'll figure some stuff out. And you know what? Part of what makes these questions challenging is there's no perfect way to solve these. There's no I have to do it exactly this way. You can just use some good old fashioned just smarts. Just puzzle solving, kind of in that kind of spirit at which you can approach the question. So try to approach it with some curiosity. I know it's easy for me to say. I'm not getting graded on it and stuff, but if you can see it as a puzzle, I think it'll be a little more enjoyable, and you can get less anxiety kind of clouding your brain. So let's see what we got. I guess the game that I'm going to play is I want to look for one of these ratios where I have two pieces of information. So either a side and an angle or two sides. I literally have only one side here. So that's probably not, it's probably going to have to be an angle and a side. So what angle can I connect to this side here? It looks like the 28 right here. That's going to be my angle. So that is an opposite. Awesome. So that is an opposite to angle 28. That doesn't really get me AB, but I could use that if I call this this one here. I don't know how to make that obvious. The AD. If I call that my hypotenuse, I could solve for that, and that gets me going in the second triangle. And I kind of need the second triangle more than anything. So let's do that. So let's say. Let's take a look at what that would look like. So I guess that's opposite of a hypotenuse. So that's the SOH, the sine ratio. So I'll start working on that here. So I'm going to find sine 28 degrees is going to equal the opposite over the hypotenuse. So our opposite is AC. That's 6 millimeters, I guess, whatever. And then the hypotenuse is AD. All right, so we can solve that. We can do our kind of cross multiplication where I can say AD is going to be 6 divided by sine 28. Awesome. So let's go math that out, shall we? Let's get rid of whatever we're doing from before, and we'll take 6 divided by sine 28. So you might be wondering, which do I use? Do I use inverse sine? Do I use sine? If you have the angle, then you press sine to find the ratio. That's what we want. If you don't have the angle, if you have a ratio, you press inverse sine. So this is a time where we have the angle, so I'll just press that. So that's 46.9, and then 6 divided by that works out to be about 12.7. Awesome. So, wait, what was it? 12.78, so 12.8. All right. So now I can update my diagram. So instead of whatever crazy thing I wrote there, I can say now that this side is 12.8, probably millimeters is fair to say. That's kind of messy. I apologize. Let's improve my writing. There we go. Ooh, so pretty. Okay, so that's progress, right? Now I have this AD, I have an angle, and I have, well, I don't have the hypotenuse, but I can use that to find it out. So what I'll do now is figure out what ratio I have. So I have 36 degrees here, and my measured side, the 12.8 millimeter side there, that's an adjacent, right? That's an adjacent side. So I have adjacent, I'm looking for hypotenuse. That's going to be my cosine, right? It's adjacent over hypotenuse. So that's the two things that'll include two pieces of information that I know. So I could say cosine of 36 degrees equals our adjacent side, 12.8, over the hypotenuse, which is AB, which is what we're looking for. So we've locked it in now. We've narrowed it down. We can do our cross multiplying to say AB equals 12.8 divided by whatever the cosine of 36 is. So I'll go to my calculator. So I'll type that in. 12.8 divided by cosine of 36, which is apparently about 0.81, and that works out to be 15.8. Cool. 15.8. So my answer, that is my answer, final answer. I guess I'll put the units in there to say, I guess AB is 15.8 millimeters long. Awesome. So, yay, we solved it. It was kind of a tricky puzzle, right? It did take a bit of time. We had to sort of work multiple trigonometric ratios to figure that out. Once we solved we also got the 12.8 millimeters, we were able to then figure out the hypotenuse for the other one. So that was great. So that's the kind of game that you're playing for question 4. And I hope that makes a little bit more sense of what you're supposed to do or how you're supposed to solve these questions. And I wish you the best of luck in finishing the rest of them. Okay, thanks so much. Math 10, take care. Bye-bye.